Welcome back, folks. Now that you guys know how to blink an LED using an Arduino, let's take things up a notch. Now I'm going to introduce you to an RGB LED. I love RGB LEDs because you can do so much with them. You can take an RGB LED and not only can you make a mood lamp out of them to change colors and go with the mood and create a vibe, but you can also program these things to go with your music. So you can actually make the lights change with the music. You can program them to create some mood settings. You can create some fun effects while you're working. You can do all sorts of stuff. So to be able to program this thing and to make this thing change color, let's go ahead and learn a little bit about this. Now, if you look very carefully, this LED, I'll just take it out for you, has 4 pins instead of 2 that we had in the last video for a regular LED. This one has 4 of them. That means there is a lot much more going on over here. So let's go onto the screen to understand from a schematic diagram as to how these things are wired up and how do you actually program them. Okay, so I'm going to put this back and hopefully this is going to align and work. So let's just put this back. Okay, done, and it's working, so that's great. Now let's look at RGB. If you look at the way that these things are designed, the first one is R, which is for color red. The second one is a positive anode in this case. There is also sometimes a negative cathode that you can get in an RGB LED, but for the one that you guys have in your kit, you have a positive anode. So we're going to stick to this example with the positive anode. Then you have a green, which is the G, and the blue. Each leg of the LED, the R, the G, and the B, control all the 3 different colors. And then there is a positive anode, which is a common anode, which gives the power to this LED so that it lights up. Okay, now to be able to create this diagram, instead of doing it on the circuit board, I'm going to do it on the computer and on a circuit designer so that you guys better get to understand this and at the same time can practice it at home. So the first thing that I wanted you guys to do is go to Circuit Studio and open Circuit Designer. You can do that by Googling it, and there is also a link below. Once you get it over here, you're going to start a new sketch. You're going to start it from scratch. Done. And in the search bar, I'm going to search for an RGB LED. So this one right here. Apart from that, I'm going to need an Arduino Nano. I can take any of these, it doesn't matter. And then I will also need a resistor. All right. The resistor that you have inside your kit is a 220 ohm resistor. So I'm going to change the value of this resistor to 220 ohms. And then I'm going to say Command C and Command V 2 times and get 3 of them because I need 3 resistors. One for red, one for green, one for blue. RGB. I'm going to try and connect this RGB LED to pin number 9, 10, and 11. I'm going to get into a little bit more detail why I'm specifically asking you to connect it to 9, 10, and 11. These 3 pins are actually PWM pins. Now, what does PWM stand for and why it makes it different to us, we'll get into in a later video. For now, I want you to connect this to 9, 10, and 11. So let's go over there. So I'm going to move these resistors and just sort of make it sort of neat and tidy. I'll move this down, move this in front of 10, and move this one in front of 9. And then what I'm going to do is I'm going to pull a cable from R, connect it to this pin. I'll also change the color of this to red. Whoops. I'll change the color of this to red. Right there, 255. And then connect this further to pin number 9. And I will keep that as color red. So I've connected the red or the R, which is the red side of the LED pin, to pin number 9. Now I'm going to connect the green to pin number 10. Once again, I'll change this color to green, which is basically 0, 255 and 0. And I will do the same for this one, so that we can always, so we are neat and organized when we're doing our work. Finally, let's create a blue connection. Okay, and as you can expect, this is blue is 255 and this is 0 and 0. Now some of you might be wondering, what is this 255 number? Where did this number come from? Do you guys have any wild guesses where this 255 number comes from? So I'm putting 0 and 0 and then 255. Think about it. And I'm going to throw in a quiz at the end so that you guys can figure out what this 255 stands for. And if any of you get it, that's brownie points for you. If you don't get it, don't worry. We'll show that to you in the next video. Finally, I'm going to take the COM. Now this COM is the common anode once again, and I'm going to connect this to the 5-volt power supply of the Arduino. And for now, perhaps we can make this into a yellow cable. Just somewhere over there. That should be good. All right. So what I've gone ahead and done is that I've created a connection from the red to pin number 9 via the resistor, green to pin number 10 via the resistor, and blue to pin number 11 via the resistor. Now these three once again are PWM pins, and finally I've also gone ahead and created a connection from my common anode to the 5-volt power supply. Now this is exactly what's happening over here, as you can see on this circuit. 9, 10, 11 and the 5-volt power supply are now connected via the resistors to this LED. So you can see that a little better in the video. Okay. Now let's get into the code to understand what exactly is going on over here in terms of the code and how we're feeding it the different amount of power to be able to turn on and change colors in this LED. So for that, we need to open once again the Arduino IDE. Okay, once you open the Arduino IDE, you would already have this 3 RGB LED code in your edX platform. So on your LMS, you should already have this. You can just download this code, so you don't have to write all of this code. And once you open it, it's going to open up just like this. Once it opens up, let's go line by line trying to understand this code. The first one, as you can see, is a comment. So this doesn't really do anything. And it says, define the pins for RGB LED. So that's the first thing that we're doing. Const int red pin is equal to 9. So what I'm saying is pin number 9, I'm just renaming it to red pin. Pin number 10, I'm renaming to green pin. And pin number 11, I'm renaming to blue pin. The reason why I'm doing this is so that my brain can remember which pin is which. Otherwise, I get confused as to which pin is which. So instead, I will just use red pin, green pin or blue pin to be able to call out pin number 9, 10, 11 to make my life easier. You guys can call them whatever you want. You can also call it G pin, R pin, blue B pin or whatever else you want. And that's totally valid. And I would encourage you guys to try that out. Then go into the void setup loop. And then I'm going to define the red pin to be the output, the green pin to be the output, and the blue pin to be the output. So now these are the 3 outputs coming out from my void setup. So I'm just setting up my Arduino to set this up as my output. Let's go below. Next, for the void loop, which is the repetitive loop, this is what's going to create these amazing colors. So the first thing that I'm doing is set color 25500. So that means set color red. So it's starting with red, and delay it by 1000 milliseconds. Once again, that's equal to 1 second. So for 1 second, keep the color red on. After that, set color 02550. That's color number green. This number 255 is coming once again, as you can see. So you guys need to answer this as to what's going on over there. Why is it 255? And why is it not 5 volts, for example? That's the maximum voltage that your Arduino can supply. It's between 0 volts and 5 volts. So technically 255 relates to the amount of voltage. How much voltage are you actually feeding in? So set color green, and that's 0 to 255 and 0. So second one over here is 255, which is green, and I am going to keep this on for 1000 milliseconds. Then after that, I'll do the same for blue. For yellow, the code is 255, 255, 0. So you can go ahead and do that, and that's for yellow. For purple, it's 255, 0, 255, because why is that the case? Purple is a mixture of the color red and blue. When you mix them up, you get purple. So that's how you get purple. Similarly, yellow is a mixture of green and red. So when you mix those colors up, you get yellow. Similarly, cyan is a mixture of, in this case, green and always actually green and blue. When you mix up green and blue, you get cyan. And white, the color white, is a mixture of all the colors in the universe. So hence, it's 255, 255, 255. That's going to give you all the colors. And we're going to delay that as for 1000 milliseconds. So as you can see, the first color that we're going to get is a red. Okay, we got a red, then the next color is green, then blue, then yellow, then purple, then cyan, and then white. So in the same order, we have all the colors coming up on this LED, and then it's repeating in a loop again and again and again for 1 second each. Okay, after that, the second thing that I'm doing over here is I'm setting up a function to set the color of the RGB LED. So I've done a void set color int red, int green, int blue. So why am I doing this? The reason why I'm doing this is because this one over here is a common anode and not a cathode. So what I'm mentioning over here, as you can see, is for a common anode, use analog write pin 255 minus value. So if you think about it, and this is something for your logical brains to think about right now, I'm providing it with 5 volts on the common anode. And the other ones, which is blue, green, and red, are given with a different voltage, which it's subtracting from to be able to provide us with the right color. What do I mean by that? Now, think of it like this. If I were giving it voltage on blue and ground was actually the common cathode, then we would automatically make sense. However, because we have a common anode, we have to invert everything. And the voltage that's being given to from the anode is always at 5 volts. So it has to be the opposite of the voltages to be able to counteract for it. If you don't understand it too much, don't worry about it. We can talk about it later and as we get into this program. Once you start doing it, you'll get the gist of it. In the case of common cathode, we don't have to really do anything. In that way, it's pretty much straightforward. In a common cathode LED, this long lead ends up becoming the common cathode, which is connected to ground. And then whichever color you want, you just add a value to it. So you pretty much don't change anything, as what we did right up here. But for common anode, we need to subtract it and actually invert all the numbers. So the first thing that I'm doing is analog write, red pin 255 minus red, analog write green pin 255 minus green. So I'm just simply inverting it. As you can see, analog right, blue pin 255 minus blue. This is just for inverting all the numbers from a common cathode to a common anode. That's about it. And if it's a common cathode, once again, that's the common, everything remains the same. You don't have to do anything in a common cathode LED. Okay, I hope you guys have questions, and if you do, that's awesome, because that means that you guys are thinking. If you have some questions, use the chat box, talk to your mentors, or schedule a call as well, and catch up with a mentor. If you don't, then make this circuit, and then play around with this circuit a little bit. Change this code a little bit. Try out a few different colors. Try out your favorite colors. And you can also try a mix of colors based on what you like. You don't need to stick to 255, 255. You can try some intermediate colors and have some fun with it. You can also try to rewire this in a different way. See what happens if you invert the colors. If you connect, for example, blue to red, red to green, green to blue, you can play around with that. See what happens when you do this. See what happens when you change the output timing to a different amount of time. Can you do that? Can you change the cord to be able to allow it to blink faster or blink slower? Feel free to do that. So the next exercise for you is to, one, figure out and mess around with this cord and try out a few new things. And secondly, is to understand the mystery of the number 255. Try and figure this out, and I'll see you in the next video.